Hello, my name is Aina Ezrina binti Zaki from EC 2204C7, and today I'll be presenting Chapter 4, Hydrodynamics, on flow rate or discharge, velocity, and the principle of conservation of mass. The first is, what is flow rate or discharge? As you can see, flow rate is defined as the quantity of fluid flowing per unit time across any section. The formula of Q is equal to A times by V, where Q is the flow rate or rate of flow or discharge. The unit is meter cube per second. A is the area of fluid flowing. The unit is meter square. And V is the velocity of the flow, where the unit is meter per second. For the first example, we have benzene flow through 100 mm diameter pipe and the velocity is 3 meter per second. The mass density is 879 kg per meter cube. Find the volumetric flow rate, weight flow rate, and mass flow rate. The solution is, first calculate the area and the velocity value from the question. Therefore, substitute all the value. Volumetric flow rate or Q is equal to 0.0236 meter cube per second. From the question also, we have the rho value and G is equal to 9.81 meter per second square. Therefore, substitute all the value. Weight flow rate, W is equal to 0.203 kilonewton per second. And lastly, mass flow rate is equal to 20.7 kilogram per second. Moving on to the velocity. Velocity is the parameter that indicate how fast and in what direction of the fluid flows. Next is the principle of conservation of mass. For a steady flow, the mass of flow entering the segment must be equal to the mass of flow leaving the segment. This is also can be expressed in terms of rho 1 A1 V1 is equal to rho 2 A2 V2, but rho 1 is equal to rho 2. Therefore, by continuity equation, Q1 is equal to Q2, where A1 V1 is equal to A2 V2. As you can see in the figure, the mass volume entering in section 1 equal to the mass volume leaving in section 2. Let's take a look at the next example. Water flows through segment 1 and segment 2 at D1 is 15 mm and V1 is 0.6 meter per second. And at segment 2, the diameter is 3 mm. So the question asks the velocity at segment 2. From the figure, the velocity of water coming out from the nozzle is V2 by using continuity equation, and we rearrange the formula. V2 is equal to A1 over A2 times by V1. We calculate the area 1, A1, and calculate the area 2, A2. Therefore, we get V2, which is velocity of water coming out of the nozzle, is 15 meter per second. The last example, that the water flows through A, B, C, and D, and at A the diameter is 0.5 meter, at B the diameter is 0.3 meter, at C the diameter is 0.15 meter, at D the velocity is 3.6 meter per second, and the diameter is 0.2 meter. The question asks to find the discharges at C and D and the velocities at B and C. From the figure, by applying the continuity equation, QA is equal to QB equal to QC plus QD. At A, we calculate the area of A and we can calculate the discharges A is equal to 0.393 meter cube per second. At D, we calculate the area of D and we can calculate the discharges at D. QD is equal to 0.1130 meter cube per second. From the continuity equation, we rearrange the formula. We get QC is equal to QA minus QD. Therefore, the discharges at C, QC is equal to 0.28 meter cube per second. We calculate the area of B. We get 0.07068 meter square, and we calculate area at C is equal to 0.0177 meter square. And then we can calculate velocity at B is equal to 5.56 meter per second. And lastly, we calculate velocity at C. We get 15.84 meter per second. That's all for me. Thank you and have a great day ahead.